Okay, this is the assignment for day 6 on data analysis, measures of spread and the shape of data. I'm just gonna jump right in. The histogram shows the results of a survey about a distance that students live from school. So here we have 2 students live 0.1 to 1 miles. Here I see 4 students live 1.1 miles to 2, and so on and so forth. What fraction of students live 1 mile or closer to the school? I see 1 mile or closer is right here. This is 1 mile or closer, right? 1 mile or closer, like 0.1 is definitely closer than 1 mile. So I see 2. But it says what fraction, right? So 2 out of what? And for that, we'll just have to add. So we see 2, 4. So I see 2 plus 4. Let's do this down here. It'll be a little more streamlined, I guess. 2 plus 4 plus 6 plus 4 plus 2. And guys, just notice that this is a symmetrical graph. It looks the same on either side of your midpoint. All right. So 2 plus 4 is 6. 6 plus 6 is 12. 16, 18. All right, so this is equal to 2 over 18. Well, does 2 go into 18? Yes, it does. 9 times. This is the answer for 1. 2, what percentage of students live more than 3 miles from school? Okay. Well, right here I see 2.1 to 3 miles. That's a possibility, but they want 3 miles or more, so we can't focus here. We have to focus 1 notch up. 3.1 to 4 definitely falls under the 3 miles, lives more than 3 miles category. All right. So let's see. What percentage? I'm gonna say, let's start with a fraction. All right, 3 miles or more is gonna be 4 plus 2, so 6 students over, 18. 18 is our total. So 18. And yeah, we can simplify this, and then we can get a better idea of, or an easier problem to divide. So top in, bottom out. How many times does 3 go into 1? How many times does 3 go into 10? 9, 1. Right. There's another implied 0 here. You can drop that down. Right. 3 goes into 10. Again, 3 times. 9. And so on and so forth. This is why I like you guys to just work in your compositional notebooks when you're showing your work. But what are you gonna do? All right. So let's see. There's gonna be a remainder 1 at the bottom here. I know you can't really see it, but that's a remainder 1. So a lot of you guys were actually pretty knowledgeable on mixed numbers, so I'll kind of skip the explanation of what I'm about to do here. But yeah, a mixed number, guys. I see 0.33 and 1/3, right? So 0.33. Honestly, you could say what percentage of students lives yada, yada, yada. I would even accept 33% as a correct answer, but since there's a remainder down here, I'm gonna take that into account. So there's a remainder 1, so our quotient is 33, our remainder is 1, and our denominator is the exact same, 3, as the original denominator. But if I wanted to convert this into a percent like they want, this is currently a decimal, 0.33 and 1/3. But if I were to just move the decimal up 2 places, that would make this whole value a decimal, a percent, excuse me. So 33 and 1/3%. That's our answer. All right. The dot plot shows the vertical jump heights for a group of athletes. Let's see. Let's start with the easy ones. What is the peak of the graph? Obviously it's 34 because it has the most dots. Where is the data clustered? Well, where is the data clustered? Well, from our last lesson, back here, a cluster is a group of data points located close together. In this example, this was the cluster. So in this example, this will be the cluster. So 33 to 34. Okay. And for the IQR, it's just the left median and the right median. I'm just gonna, like up here, we have a little space. I write all my data points out, right? So I've got 33 two times. Got 33.5 two times. I've got 34 four times. I've got a 37.5, and I've got a 38. All right. Our median, we can just crawl our way in. Okay, we've got two middle numbers. When I add these two and divide by 2, here's a little trick. If your middle two numbers are the same, your median's gonna be exactly that. Just one of these, just pick one of these numbers, but I'm just gonna write it out here. Our median is 34. All right, so 34 plus 34, and then divide that by 2, you get the exact same thing, 34. That's not always gonna be the case if these two numbers are different. Okay, so now that we have our median, the IQR is just equal to the right-hand median minus the left-hand median. So we're just gonna say, so 34 minus, what is the IQR? Minus the left-hand median, which is 33. I'll just write my dots up here. 33, 34, 33, 33.5, 33.5. 33.5 is our median on the left-hand side. All right. Yes. Oops, excuse me. So many 34s flying around. 34 minus 33.5, which is 0.5. Okay. And yeah, the rest of this is a similar fashion. A trick here, they already give you the right-hand median and the left-hand median. The left and right edges of the boxes are the exact same thing. So you can skip all this. You don't have to write any data out like I did there. You can just say 14 minus 11. So the IQR is equal to 14 minus 11, which is equal to 3. Right. So 0.5, 3, 4, 4. What is the shape of the graph? It's skewed left. I knew that because the tail is all the way to the left, just like in this picture here. But up here you should have skewed left. Fewer data points on the left. All right, 75% of the data clustered. That's easy, that's gonna be 11 through 15. Because this is 25% and the rest of the 75% is over here. What is the range here? Let's see, skewed right and okay, so let's start with something easy. Actually, I'll let you guys handle this part. You should be familiar with all these. What I kind of want to go over here is the quarts to cups. I've been told you guys haven't gone over unit conversions much, but there are 0.25 quarts in 1 cup, right? Quart to cup, right? And then you can just say that is equal to 8 quarts is how many cups? You can use scale factoring, you can use cross multiplication, you can use whatever you want. But at the end of the day, you should get 32. And that's that.